go by twos, for our x-axis for our first graph. So I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Obviously this is 0. For my y-axis, I'm going to go up by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Alright, so this is our income. That the store makes. And this down here would be the number of strings. So obviously if we sold 0 strings, we would make $0, right? So I can put a point right here. If I sold 1 set of strings, I would make $6, which is somewhere in here. 2 sets of strings, I would sell them for 12. And we can just go up and use these lines instead of going the halfway mark. So 4 sets of strings, $24. 6 sets of strings would be $36. 8 sets of strings would be $48. 10 sets would be $60. 12 sets of strings would be $72. See, I'm just multiplying by 6 each time. 14 would be $84. 16 would be $96. And then we actually get off our graph. That's as far as we can go. So since this is a linear function here, we can draw a line and connect all these dots. Because the number of strings, the price, or the income that we make is just going to continue to go up. For my next graph over here, I'm going to use the same numbers. 0, 10, 20, 30, 40. Alright, this says at Store B, the guitar strings are $20 for a pack of 4. So, over here at Store B, I know at 4 strings is going to be $20. Well, if I only need 3 strings, it's still going to be $20 because that we can only buy in packages. If I only need 2 strings, it'll still be $20, or if I only need 1 string, it'll still be $20.
Teachers, please excuse the 11th graders with last name S through V to the cafeteria with a pen or a pencil. 11th graders, last name S through V. Thank you.
Alright, so if they come in packages of 4, after a pack of 4, I would have to go to a pack of 8, or 2 packs of 4, would be 8 strings, and that would be $40 since they're $20 each. Alright, if I had to buy 3 packs of 4, I would have 12 sets of strings. But this time I'd have to spend $60 to have between 9 and 12 sets of strings. I mean 9 and 12. And then it would be $80 if I wanted to have between 16 and 13 sets of strings. And then if I actually wanted 20 sets of strings, it would cost me $100. Alright. Part B now says, describe the shape of the graph for store A and describe the shape of the graph for store B. Why are the graphs different? So I said the graph for store A is a straight line. And then I said the graph for store B jumps between flat sections. It's not a straight line, it jumps between flat sections because of the packaging deal. So the graph for and then why are the graphs different? So they are different because store B sells by packages and store A sells them individually. Alright, now they want us to compare the graphs for stores A and B. For which numbers of guitar strings is it cheaper to buy from store B? So if I want to just buy one guitar string, one right here, it only costs me $6. Where if I just needed one guitar string at store B, it would cost me $20. If I needed two, it would cost me $12. Store B would cost me $20. If I needed three, it would cost me $18, where at store B, it would still cost me $20. However, if I needed four strings at store A, it would cost me $24, where at store B, it would just cost me $20. So, for what numbers of guitar strings is it cheaper to buy from store B? I know 4 guitar strings is cheaper to buy from store B. 1, 2, or 3 would be A. Alright. Next would be 40. So what's below 40 here? 8 would be above 40. 7 times 6 would be 42. So that would be below, 7 times 6 is 42. That would be above the 40. So numbers 7 and 8, you needed 7 sets of strings or 8 sets of strings, would be below that 40, or it'd be cheaper at store B. Alright, between 11 and 12, excuse me, 9 and 12. 9 is 60, let's see, 9 here would be below 60. 10 would be right at 60, so it's not necessarily cheaper at store B. 11 is above, it'd be 66, so 11 sets of strings would be cheaper at store B, so would 12 sets of strings. Let's see, 13 would cost us $80 here, where 13 is right below 80 if I'm looking at my line here. 14 is above 80. So 14, 15, and 16. And then it looks like 17 would have been above 100, which it's right at 100 here on store B. So 17 through 20. 17, 18, 19, or 20. So it would be cheaper if you needed this amount from store B, or to buy from store B. Alright, let's go to page 10. Alright, that's modeling with a piecewise defined function. Alani has a summer job as a lifeguard. She makes $8 an hour for up to 40 hours each week. If she works more than 40 hours, she makes 1.5 times her hourly pay, or $12 an hour for each hour over 40. How could you make a graph and write the function that shows Alani's weekly earnings based on the number of hours she worked? So it says first make a table of values in a graph. So what they did is they took 20, multiplied it by 8, 25, multiplied it by 8, 30, multiplied it by 8, 35 by 8, and 40 by 8 to get these numbers here for her pay. And then at 45, they used this function right here where they took $8 times 40 plus $12 times x minus 40. So for 45, that would have been 45 minus 40, or 12x minus 160 because they simplified things out. It says notice that the plot contains two linear segments with the slope that changes slightly at x is equal to 40. So we had a constant slope of $8 an hour right here until we got to x equals 40, and then our slope changed to $12 an hour. A function that has different rules for different parts of its domain is called a piecewise defined function. So they came up with this graph. They said that 8x, or we're going to use 8x if the hours she worked is between 0 and 40, and 12x minus 160 if the hours she worked is greater than 40. So they just want us to figure out how much she will earn if she works 37 hours, or how much she will earn if she works 43 hours. So we're going to use these two equations. Let me come over here and write them. So we got P of x equals hold on just a second. So because we've got two different parts, we've got P of x equals 8x if x is between or equal to 0 and 40. We're going to use 12x minus 160 if x is greater than 40. Minus 160. So all we're doing here is deciding which equation to use to plug in to figure out how much she will make if she works. For instance, 37 hours. 37 is between 0 and 40. So I'm going to take 8, multiply it by 37. So if Alani works 37 hours, can somebody with a calculator help me out here? How much will she make? 296? All right. This time we're going to see how much she would make, or how much her check would be if she worked 43 hours. So since 43 is greater than 40, we're going to use 12x minus 160. So 12 times 43 minus 160. 356. Her check would be $356. All right, next what we're going to do is we are going to graph a piecewise defined function. It says graph the piecewise defined function where the domain and range, and over what intervals is the function increasing or decreasing. All right, so the easiest way that I can think to do this is to use symbols. So I'm going to use a star for this first graph, a heart for the second, and an exclamation point for the third. So what I'm going to do is I'm going to go to, or actually first I'm going to make a table over here in my little margin. And if you look at the, all right, because there is a line under the inequality symbol right here at -2, that also tells me that this is going to be a closed circle. Well, how can we figure out what these y values are? That's where we use our calculator. So I'm going to go to y equals and put in the equation 2x plus 5. And remember, I'm only worried about the x values from -6 to -2. Y'all remember how to get to the table? You get second graph. And I am only worried about -6 to -2. So we got -7, -5, -3, -1, and +1. So -7, -5, -3, -1, and 1. Well, they didn't do a good job. I wish they would draw the axes on the graph for us. But they don't. So let's go down to and then I'm going to draw my y-axis. I'm doing this so that I'm able to fit everything on the graph. So -6, -7. Close circle. -5, -5. -4, -3. -3, -1. And -2, 1. To make sure that I draw this function correctly, it is a straight line, but I'm only going to connect these dots that I have here. Alright, so now we have gotten the first part of this. Now we're going to focus on this second equation. But this time my x values only go from -2 to +1. So -2, -1, 0, and 1. And this is the heart equation. So I've got 2x squared minus 7. And we are worried about values from -2 to +1. So -2, +1, -1, -5, 0, -7, and 1, -5. So -2, 1, 1, -5, 0, -7, and 1, -5. You see this inequality symbol right here? What does that tell me about that starting point at -2? Is it an open circle or closed circle? It's open circle because there is no line underneath our inequality symbol. All right, at +1, again, there is no line underneath that inequality symbol, so it is also an open circle. So -2, 1 says it's an open circle, but look, that one's already closed for us, isn't it? So can I change it? No, we're going to keep it closed if it's already closed, okay? Then I've got -1, 1, 2, 3, 4, 5, -5, 0, -7, and then positive 1, negative 5. Let's see what the shape of this graph will look like. Alright, obviously we're not graphing the whole thing because we stop here at 1. So do you see what it should look like? Kind of like a parabola, just not the whole thing. So we know we're stopping right here. And what did I do wrong right here at 1, negative 5? What kind of circle should that have been? Open circle. So that portion of the graph should look something like this. Alright, and now our last equation. This one's represented by the exclamation point from 1 to 3. So just 1, 2, and 3. It's going to be, you could put it in, but I'm going to tell you this is negative 5, negative 6, and negative 7. All I did was just plug it in myself. It says at 1, I should have a closed circle. And also at 3 should be a closed circle. So 1, 1, 2, 3, 4, 5. It's an open circle, but what should I change it to? Closed, if it's not already. And then we've got 2, 1, 2, 3, 4, 5, 6, 2, negative 6, and 3, negative 7. And it's a straight line. And we stop there. Alright, let's focus here now on the domain and the range. Domain, remember, is your x values. Alright, it looks like my smallest x value happens right here at this point, which is at 1, 2, 3, 4, 5, 6. So negative 6. It is a closed circle there, so I'm going to say negative 6 is less than or equal to. We're talking about domain, so which variable do I put in the middle? X. Alright, let's see if I have any breaks. If I follow this graph along, there are no breaks. There are no open circles, and like I said, there are no breaks in anywhere. We have a point at negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and 3. We don't stop until we get to 3. And at 3 we have a closed circle, so I'm going to say is less than or equal to 3. Smallest x value to the largest x value. Next we're going to look at our range. Range is your y values. My smallest y value, I've got 3 of them right here that are all the same. And that's 1, 2, 3, 4, 5, 6, negative 7. Is less than or equal to y. Alright, it looks like we may stop right here, but if you notice, this line's going to keep going up, right? So we don't have a break in our range there. So I keep going up, I still have a range. This looks like it's my tallest y value though, or my largest y value. My y value there is a positive 1. let's now take a look at the second graph. I know you probably don't have much room over here, so I'm going to put those tables over here as well. So I'm going to use, again, asterisk, heart, and exclamation point. I can go ahead and tell you that we're going to just draw this one straight down the middle. We'll be good to go if we draw it there. Alright, so I'll start over here with the first one. -4 to 0. So -4, -3, -2, -1, and 0. And this actually tells you what your y value is. This tells us that our y value is 3. So 3, 3, 3, 3, 3. At -4, I should have an open circle. At 0, I should have a closed circle. So let's see, we got -1, 2, 3, 4. Go up 3. Should be an open circle. -3, 3, -2, 3, -1, 3, and 0, 3. Hey, do all your books have a 0 right here? Because actually in my workbook it had a -1, but I noticed on the example in the book was a 0. So I don't. So mine So I just changed mine. I just read over it. All right, so we're gonna connect these dots here. All right, next we're going to have -x. This is our heart, where I've got 0, 1, 2. So we're going to have 0, -1, and -2. At 0, 0, it should be a closed circle. Also at 2, -2 should also be a closed circle. So 0, 0 is closed. 1, -1 is, and then 2, -2 is also closed. And I'll connect those two, or those three, excuse me. Alright, and then our last one. From 2, 3, and 4. So this will be 1, 0, and negative 1. At 2, 1, it should be an open circle, and also at 4, negative 1 should be an open circle because of our inequality symbols here. Alright, this domain and range is not as easy as the one it was for part A. Again, remember domain is your x value, so we look left to right. My smallest x value, even though it's a closed circle, is right here at 1, 2, 3, negative 4, okay? It is a closed circle, so that means that inequality symbol is, or does not have a line underneath it. Keep going. I've got a value at 0 and it stops, but it picks back up with the second part, the one that was the heart equation here. It does actually pick it back up. So as long as when one segment stops, the other one starts, it doesn't have a break in your domain at all. So we're still going. We've got a value at 0, 1, 2. I've got an open circle and a closed circle. So again, there is no break between the two because there is a closed circle here. Had they both been open circles, that would have been a little bit different. Alright, so we've got a value at 1, we've got a value at 2, we've got a value at 3, and then I've got an open circle here at positive 4. So I'm going to say is less than 4 because of that open circle at 4. So our range is actually what's a little bit different for us. My smallest y value happens here at negative 2, so I'm going to go ahead and write that at negative 2. I've got a value at negative 1, I've got a value at 0, and at positive 1, I've got an open circle. So I'm going to say is less than, oh, that should have been less than or equal to, why? Because it was a closed circle. But at positive 1, it's an open circle. So I do not put a line underneath my inequality symbol. However, I've still got some y values up here. I just don't have a y value at 2, or in between 1 and 3, really. I don't have any y values. So I'm going to say and y equals, because it equals one certain thing right here, y equals 1, which is 1, 2, positive 3. Alright guys, and we're actually going to stop here for today because I don't want to run out of time, and that took a little bit of time for us to do those three examples we did today. We'll pick up with examples 3 and 4, or 3, 4, and 5 tomorrow. You could probably, if you wanted to, do problems 6 and 7 tonight. That I won't be checking them necessarily tomorrow. I will check them all on tomorrow's Tuesday. I'll check them all on Wednesday. But if you just want to do a few tonight to get them over with, you could, or you can do them all tomorrow night. I don't care. Okay. But if, like I said, if you want to do a few tonight, you attempt problems 6 and 7.